So I'm going to be talking about PID and I controllers. So over here, I've got a system as it responds to a different function here. So first it's going to shoot up and then go kind of hone in on that. So this would be an example of a proportional controller because it just looks at the distance between itself and the target, and then it adjusts accordingly. But you're going to want some more complex things. Because for instance, if you had a different transfer function, let's say, you've got your target and you want it to go up like that or something, up and then down or whatever, you're going to need something more complex, so you use the integral and derivative parts. So the integral part is going to look at the area here. It's where the transfer function is at, and then where the area under there, and it's going to use that to adjust the damper. Whereas the derivative portion, it's going to look at the slope of that line, so how fast you're getting to the target, and then it's going to want to hone in and make the slope relative to the target 0. So that's just kind of to help you stabilize on the target there. And so when you go to tune these things, you're going to want to play around with them. First, you should play around with the proportional part, then the integral, and then the derivative. I guess the block diagram looks something like this. So you have all three of these. That go in together and affect your plant. So you got all three of them. You got the proportional part, the integral part, and the derivative part. Those all sum up together and affect the plant. And the goal is, just like any other control system, is you want to hone in on the target. The PID controllers have the advantage of being simpler to understand and simpler to control and change, as opposed to some of the other control strategies that are out there. So.